Good morning, one and all. Today we are going to discuss about tautology and contradiction. So first, I'm going to tell you what is tautology. A tautology is nothing but whatever the operation here you are going to do. You observe here P and Q. If you do some operation P conjunction Q or P distinction Q, once you do the operation final output, if you found all output should belongs to one, then we call it as a tautology. What it says, a compound proposition which is true for all possible truth values of its component is called tautology. In the sense, if you are having a p values along that q values, you are doing some operation using p and q values, you got the output as both are true value, one in the sense true output, so all output belongs to true, then it belongs to tautology. At the same time, what is contradiction? A compound proposition which is false for all possible true values of its components is called contradiction or absurdity. So in the sense, it's in a reverse manner of tautology. For example, using these elements, if you do some operation, if you get true value, that is tautology. You the same thing, if you're using this element, if you're doing some operation, so you observe here p is having 0 and 1, negation p is having 1 and 0. Using this p disjunction negation p, sorry, p conjunction negation p, sorry, p conjunction negation p, in a sense 0 negation conjunction 1, so output is 0, 1 conjunction 0, the definitely output is 0. So both output value belongs to false or 0, that time this compound proposition, this compound proposition, we call it as a contradiction. The same manner, and another one thing is, what is contingency? In a sense, a compound proposition that can be true or false is called a contingency. So in this sense, a compound proposition that can be true or false. For example, while you are doing the value in this compound proposition, you got the output, all the output belongs to false, then it is a contradiction. All the output belongs to true, then it is a tautology. But what he says, while doing the operation, or if the output belongs to, some of the output belongs to false, some of the output belongs to true, that time that compound proposition we call it as a contingency. Anyhow, I explain this example using this one. So we go for the second example. Before that, I will explain once again. Prove that for any proposition P, the compound proposition P disjunction negation P is a tautology, and the compound proposition P conjunction negation P is a contradiction. So P negation P using, so P is 0 and 1, negation is reverse of that one, 1 comma 0. So first operation is P disjunction negation P, P disjunction negation P. You observe here 0 comma 1. If any one input value belongs to 1 in disjunction, the output is 1, then definitely output is 1. Here also 1 comma 0, in the sense output is 1. So all the output at the point of this operation, it belongs to true, then we can easily say that it is belongs to tautology. The same manner, if you observe here P conjunction negation P, so conjunction in the sense what it says, all the output should be 1, then only output is, all the input should be 1, then only output is 1. Otherwise, if any one put belongs to 0, definitely our output is 0. Here you observe, in this one, here having 1 0 value, so definitely your output is 0 only. Here 1 comma 0, in the sense definitely your output is 0 only. So you got all the output is false, then what it is? It is called contradiction. The next question we have to see. Show that for any two proposition P and Q, show that any two proposition P and Q, you observed here P exclusive distinction Q and distinction P bidirectional Q is a tautology. First we have to write this question. P, that is exclusive distinction P exclusive distinction Q bidirectional P comma Q. Conjunction distinction. So given question is like that, correct, right? So this one you have to prove. Before that, here we have to observe P as well as Q, in a sense P in the sense 0 0 1 1 0 1 0 1. So first you have to do this operation, correct, right? Next is this operation, correct, right? Finally you have to do this operation here. Fine. P bidirectional, sorry, P exclusive distinction Q. So in the sense exclusive distinction, in the sense any one input should belongs to 1 and remaining another input belongs to 0. That type of rows we conclude it as a 1. If it belongs both 0, then output is 0. If the both input belongs to 1, the output is 0. So this output is 0, here this row output is 0. Here you observe. So in two elements, one element should be true and another should be false. Those elements only, those rows only we conclude it as a 1. So P exclusive Q is output is 0 1 1. P bidirectional Q. P bidirectional Q in the sense, what is the P bidirectional Q? P bidirectional, P implies Q conjunction, Q implies P. So finally the output you comes P biconditional Q. So P biconditional Q, you already know that. So 1